Hello, Sheikh Jawal Ahmed from Fat Cat Motorsports. This is the second part of this video on how do you qualify your suspension vendor, or how do you not F up your suspension when you pick a new one. Or if you are going to buy a vehicle and you want to maybe ask the dealer some technical questions. Wouldn't that be interesting? You show up there armed with some zingers and see what the salespeople like go, flat what? You know, so that would be a very interesting experiment to do. So I'm going to focus on this in the second part of the video, and what I call sort of bonus questions. I could have even considered the sixth question to be a bonus in a way, but there are vendors like Volkswagen who do a lot of sophisticated tuning. They do have their factory, the non-GTI or the non-sport Volkswagen are probably some of the best designed, best tuned suspensions you're ever going to find. My friend Peter, who I met through Phil Douglas, Phil used to work at Aftershocks in Mountain View, and Phil's doing his own thing I think right now, but he's an OG. Phil was building motorcycle suspensions on and off-road focused for decades, and I met him in 2003 if I remember correctly. And so I actually met Phil through Peter, because Peter was lurking on the Miata forum and Peter made a post. And so without going into great detail, I want to focus this, but Phil was a very adept rider and suspension builder. He talked about how compression is your friend, compression damping is your friend. So he was the first person to show me what it's like. And then Peter and I would talk about theory a lot, and theory and practice. So Peter was a mechanical designer, is a mechanical designer, and he would take the shocks apart and do all kinds of cool modeling of what the components were, trying to see like, wow, Volkswagen did all these cool things with their shocks. I wonder what their intention was. So he very much respected what Volkswagen did, and there's probably other vendors that do some of this. And you can also tell by how does it ride, like what's your subjective experience, and what's a whole bunch of other people's, that becomes like a consensus level of reality that, okay, this is objectively good, this is better. So the three other bonus questions that you can ask, depending on what people are willing to share with you, are: what is the stiffness and length of your bump stops? You know, what do you have front and rear? This is important for several reasons, from both a ride quality standpoint, and from a handling standpoint, and from a handling consistency standpoint. So as I've talked about in the first series of videos, when I talked about the initial, the crucial ride harmony concepts, and I had on the board, the factory creates flat ride sometimes. And if you haven't seen those videos, I would really encourage you to go and watch them. Put a lot of love into putting that together in a coherent framework, I hope. I intended to. And I think I accomplished my goal there. So the factory bump stops come into play very early in the front. Now, most aftermarket vendors are going to give you a firmer set of springs to avoid getting into the bump stops immediately. Although sometimes they may not give you flat ride, they might end up giving you a higher front frequency or pitch. And we already know, if you've spent any time watching videos, if you've experimented yourself, pitch is the dumps. Okay, it's not the shiznit, it's the bad shiz. So you want to avoid pitch, and you want to avoid getting into the bump stops, especially in the front, too early. That's one factor, because that's a front bump stop that's too close to engaging is going to create this bucking behavior. Also, from a handling consistency standpoint, I actually had a conversation with Emilio, this is an online conversation with Emilio at 949 Racing, and this was, I was talking about helping people improve their suspension setups, and I had posted some suspension spreadsheets for Miata users, and I said, if you put in your springs and your sway bars and bump stops even, you can look at what the car does. If it's just like cornering without the bump stop engaging, and then cornering with the bump stop engaging. And then somebody had commented on how they actually changed the springs on the 949 setup, is the initial 949 Racing setup had pitch. It was like 800, 500, or 700, 400. That was very common. And that gave about, I think, 2.1 hertz front and about 1.9 hertz rear with that combination. So that's higher front and softer rear. I would normally use something like 600, 450, which would give some flat ride. And so Emilio had said, if the rear suspension on the 949 engages the bump stops, it stops working. And I need to go back and find that exact comment, but I clearly remember seeing that. And that's when I saw that, I'm like, that's strange. I mean, I can understand how that can happen. I just don't understand why you would let that happen. Because if you, the reason why it would happen is if you're using the same density. So this is, for example, the Speedthing white, 58 millimeter white. So this is about a 200 pound per inch bump stop. If you use the same bump stop front and rear, then you can get a firm engagement on the rear, which could cause the car to abruptly change its handling balance, its cornering behaviors. So for a long time, is the first things I started experimenting with actually were bump stops. That was the initial part of Fat Cat's existence, was me just creating bump stop kits. I found these different bump stops available, and I started experimenting. And do I want to have softer front, stiffer rear, depending on what you want to do? So I got very comfortable playing with different bump stop stiffnesses and lengths of bump stops, and then also these beautiful little creatures called packers, or these spacers that you can put over the shock shaft to engage, put it over, and then it makes the bump stop engage a little bit earlier, which increases the spring rate just a little bit. So when Emilio made that comment, I was like, well, and I looked at photos of the Zeta, I said, well, this must have the same, I would say it has too firm a rear bump stop. And that seemed to be the case, because I actually got a call from a gentleman who will remain anonymous, but he told me, and he's a national level autocrosser somewhere in the east of me. I'll just be that vague. And I've met him at Nationals, a very cool guy, and he said, hey, Shake, I'm co-driving this car that has Zetas on it, and it does pretty well, although it's really hard to keep it from just snap spinning on me. It's really hard to keep it consistent. And so I said, well, how about you do this? Why don't you buy some 58 Reds? So these are about 100 pound per inch density bump stop. So he went and got them, and had them installed. He's like, it worked great. The car's way more stable now. I can put power down. It's much more consistent coming out of turns. I'm like, that's awesome. And it was a very simple and very inexpensive fix. So this is maybe more relevant to more, obviously, the people who are more racing, more competition focused, which again is why this is sort of a bonus series of questions, not just for racers. The second question is relevant to everybody, but this one would definitely be relevant to somebody who's trying to push the car to the limit and expecting or wanting there to be a consistent response and a predictable response. Because the bump stop engagement, along with rebound bias damping, this being out of whack, the damping behavior, and the bump stops being the same front and rear, especially if it's a firm bump stop, together can get into a very unstable handling situation. So the eighth question, the second bonus question, are my struts inverted or non-inverted? And I've talked about this in, I believe it was the second video, and so I'm just going to illustrate this again, that there's differences in the gas force that comes from this. So if you ask the gas force question, that can give some hint of, if they can tell you that, great, if they tell you what the gas force is. But if they don't tell you what the gas force is, and you just ask them, is it inverted, meaning the tube is actually flipped upside down, this is the actual shock tube, and the shaft is inside the strut housing here, or is it non-inverted, where the shock tube is here, the oil and the nitrogen is here at the bottom, and then the shaft is above. So the non-inverted will have higher gas force by a large factor, because they usually use 18, 19, 20, 22 millimeter shafts, and it's going to actually have more unsprung weight because there's more mass down below sitting on the hub, versus if you have an inverted setup. Now you've taken the shock weight, or this tube, which is basically the damping part of the strut. You've taken the damper and mounted it to the chassis, so you've reduced your unsprung weight. So there's advantages to that. And it's not just advantages, it's also the cost of having a high gas force on the damper, which creates all this jarring and jittering and busyness. So that's a question that's worth asking. And somebody had approached me recently and sent me a matrix that had BC coilovers, and they had all these different examples and options of inverted, non-inverted, different piston, and actually that's why the last question is about piston type. But on his particular car, what was available was both of the dampers that were available, the packages were non-inverted. And so I told him, okay, let's just do some simple math. Okay, the shafts are 18 millimeters or more, and I think he found out that they were 18. Non-inverted, meaning like this MCS, so whatever nitrogen is pressurizing the bottom, you're going to feel that on this rod, and the larger the rod is, the higher the gas force, because pressure times area equals force. That's a basic equation of the relationship of pressure, force, and area. I can put this here. Well, that's a terrible color. That's probably why I haven't used it very much. Very washed out. I'll just go with black. So pressure equals force divided by area, or force equals pressure times area. You multiply, right? So the larger the area, the higher the force. And this is not a good thing. Off-road racers, anybody who's really trying to maximize grip, always say, and any shock designer will say, we want to try to get the gas force as low as we possibly can. There is no benefit to having high gas force. With monotubes, you need to run enough pressure. So monotubes will give you more precision. They will give you advantages. You have better heat dissipation. However, a cost of monotubes is often you get a lot of gas force, a lot of rod force. And again, if you have any provision to do high frequency filtering, that will help with some of that chatter. It'll allow the damper to cycle a little bit. Also, if you have a way to just not overpressurize the damper in general, then you're going to get the benefit of the less rod force as well. And so the last bonus question is, what type of pistons are you using? And usually the choices are between linear, digressive, etc. So what does that mean? I will comment on this there. So I'm going to take out some of these questions here, because we've already covered some of this. So let me just give a little bit of room so I can just do a couple sketches of what a damper dynograph might look like. So, and this is important for, is your suspension going to jack down or not? Is it going to be losing travel, or decreasing the available travel over every bump, or is it going to be able to maintain? And also, is it going to do that more on smaller bumps, bigger bumps, very sharp bumps? Because a linear damper is going to continue to build force. Linear has its advantages, but it really depends on the application. If you're doing off-road tuning, you want the damper to be consistent over large strokes, then you're probably more likely to use a linear piston. But for road-going dampers, that's usually a recipe for a very harsh ride. So here's, say, what a linear damper might look like, and I'm going to make this very dramatic. So this is going to have just a pretty much constant departure from the zero force line. My physics math teachers would scream at me for not putting axes in there, but here we go. So this is compression and this is rebound. So again, compression is trying to push you up, rebound is trying to pull the car back down. So a linear is going to have just a constant slope. And same thing with the rebound. It's going to basically be constant. There might be a little bit of a bend initially, and then it just keeps building. There's no blow off, which means that as you go to faster and faster shock speeds, or bigger and bigger bumps, or just driving on the same road at higher speeds, you're going to get this imbalance between the two. Could be, so for example, if this is 100 pounds, this is 300 pounds, you have a 3-to-1 ratio of rebound to compression. That's huge jacking down. That is going to feel very uncomfortable. It's going to get there in a very smooth way, but you're going to progressively get more and more packing down. So that's very, very sharp. And now on a digressive piston, usually what you'll find is that it'll build up more and then it'll kind of roll off. And then on the rebound, it might also build up and then roll off. Now I've tried to draw these to, let me make this a little bit actually more subtle, because yeah, that was a little bit too generous in terms of slope. So you can see that typically a digressive piston is going to have an initial slope through a certain region, and like kind of the low mid-speed region, 3, 4, 5 inches per second, where the knee exists. That's basically where this goes into its blow-off region. Blow-off meaning that the shims that are on the piston are going to open up, and then the flow is basically constant. So that's why you get a constant slope beyond the initial rise. Whereas on a linear piston, there's the port flow is very constant. It's actually constricting the fluid more, so it just keeps building, and there's no provision. Even as the shims open up, the force just keeps building in this constant fashion. Where on linear pistons are usually going to be, you're going to have like circular ports. That's usually what you see. Whereas on a digressive piston, you'll see, I just flip the colors, you're going to see more rectangular ports. So it'll be more clearly, there'll be more area. So as the damper goes into blow off, that's the center of it, there's more flow through the piston. So it gives you more softening if you're seeing a digressive piston. So let me just label this digressive and linear. Now, linear pistons are cheaper to manufacture because you can basically do everything almost on a lathe, just turning the chunk of aluminum, and you just drill position holes and rotate and can drill holes all in the same operation. Whereas digressive, you basically need a lathe, you need a mill, because you're going to have to hog this out in some non-linear pattern, not just like a hole in and out. So like the Bilstein digressive pistons are pretty sophisticated, and they've gone through a few iterations, and they also have a check valve capability, which is really cool. I won't get into that right now, but there's the virtues of digressive is you get better compliance over bumps, because instead of the constant building of force, instead of going here where normally say a linear would just kind of keep going, it's actually softening the response, so you get better bump absorption. And that's on the upward part of the bump, and then on the downward part, or on if you're going over the bump, that's compression. As you're coming down, then that's rebound. That's where the tire's trying to go down. The first part, the tire's coming up, it's being impacted by the bump, and then on the second half, it's coming down. So on the second part, again, instead of being kind of this constant buildup of a linear, you have again a decrease of the high-speed force. It's less trying to jack you down. However, it's still usually the case, depending on how somebody's designed the damper, that the digressive piston is still going to have a bias. I mean, maybe it's less than this. Again, this can actually be way more than 3 to 1. It just depends. But maybe you're at 2 to 1. Okay, rebound to compression, the ratio rebound to compression. But that's still jacking down. But at least the overall force levels might be a bit lower, so it'll be less uncomfortable. So even though the word linear sounds maybe good in terms of pistons, you do not want linear pistons for a street going or a race car. There's a Olin's guy, I think, has videos, and he's all about linear, and it's I've tried them, I've used them. There's applications when it makes sense, but if it's on a street car, track car, you can get away with it kind of for autocross, sort of, but the velocities still get pretty high in autocross. I've seen 30 inch per second spikes at Lincoln Air Park, at Nationals, because I think they're still running it there. This was back in 2011, last time when I had a date acquisition on a car that was running Nationals, an RX-8, and you could see pretty sharp spikes. So if you get to 30 inches per second and you have a linear piston, that's creating a lot of force and a lot of abrupt response. So this gives you, between the previous video and this one, these are questions that you can ask. I'm trying to give you some background on why the questions matter. And a large part of my approach is I want to tailor your suspension setup for your needs. Asking you enough questions. If you've seen my consultation form, you'll know that it's pretty long. If you haven't seen it, you can take a look. I'll likely put a link to it in this description. So I want to tailor the setup to your needs by asking you questions, by asking you corner weights. I mean, requiring it. Anybody who works with me has to provide corner weights so that I really know what are we building for. What is the car going to look like in its final form, as we say, right? Versus something generic. you know, or as I say, something optimized versus off the shelf. So I think you can ask a few questions, and maybe there's vendors out there that will take feedback and or take your questions, and maybe they'll be willing to work with you. And I think over time that ought to be de rigueur. There should be the norm of, yeah, people need to ask you enough questions so that you're avoiding some of these negative behaviors. You can avoid the pitch is, you know, bad, and avoid, you know, the jerk, the harshness, the lack of ride, and don't be victimized by the marketing. Okay, that's the big part of a lot of what I've come to realize, is that the idea of what a sports car or sporty suspension should feel like versus what it really needs to do, it's counterintuitive until you experience it. And it's like you want to be in a plane that's smooth and just getting from A to B with as little turbulence as possible. You're happy when the plane is not having turbulence. Imagine a car that can give you a smoothness to it while still having a measure of control. That's what you ought to expect your suspension to be able to do. So thank you again for watching, and I know I'll have other videos, but this is going to give you the targeted questions and the reasoning behind it. So thanks again. Take care.